expectancy at birth with current health expenditure, population, share of people who trust doctors and nurses in their country, estimate of current tobacco use prevalence, and GDP per capita in 2014. So there will be 5 chapters that I will be explaining, which are introduction, literature review, data description, and methodology, result and conclusion. So first is introduction. Life expectancy at birth is the average number of years a person will live after birth. The fundamentality is that socio-economic and environmental factors influence life expectancy in both independent and interacting ways. Every government's main goal is to increase the population's life expectancy. On average, residents of a country with good living standards live longer and have a lower mortality ratio. The major goal of this paper is to look into the factors that influence life expectancy in different countries. Countries with underdeveloped educational and healthcare systems have harder time achieving long-term development. So the article investigates the relationship between the current health expenditure, population, the percentage of individuals who trust doctors and nurses in their country, current tobacco use prevalence, and GDP per capita. The hypothesis for this study is that current health expenditure will have a positive relationship with life expectancy. There are 2 objectives for this research, which are to measure the effect of current health expenditure, population, share of people who trust doctors and nurses in their country, estimate of current tobacco use prevalence, and GDP per capita on life expectancy at birth. Second, to determine the most important factor that influences life expectancy at birth. Next, literature review. So, I use article which Elsevier BV is the publisher. So we use a fixed effects model on country level data to evaluate the association between the 2 variables, which are dependent variable and independent variable. The study begins with a summary of prior research on the link between health outcomes and health resources. The purpose of this research is to investigate the relationship between the inputs and outcomes of healthcare systems. As the topic is life expectancy at birth, that is the inputs, then the outcomes are the current health expenditure, population, share of people who trust doctors and nurses in their country, estimate of current tobacco use prevalence, and GDP per capita. So according to a study by Elizabeth Jabbar, Christiana Brigade Barana, and Lone Bogdan Robu in 2014, most countries have improved health outcomes as longevity has climbed continuously and newborn mortality rates have reduced, all while health expenditure have increased. So to estimate the life expectancy as a function of health expenditure, we use panel data analysis. Next, according to Ramesh and Mirmirani 2007, Batagi and Moscow 2010, health expenditure, number of physicians, number of hospital beds, and number of computed tomography scanner are all indicators used to assess the resources of health systems. In this study, life expectancy is taken into account while judging one's health. Previous research on the relationship between health resources and health outcomes has varied in terms of the variables assigned, the model method used, and the nations researched. Health expenditure have a large favorable impact on life expectancy and a considerable negative impact on death rate, and according to research based on a study from Pedro Antonio Martin Cervantes, Nuria Rude Lopez, and Salvador Cruz Rambaud 2019. A review of the empirical literature demonstrates the ability of research that use a global methodology and macroeconomic data to examine the primary factors of life expectancy. Next, data description and methodology. This is a technique for solving a research issue in a systematic way. So the method that I have used to collect the data is called sectional sample. It is basically about the number of years a newborn infant will live if prevailing patterns of mortality at the time of its birth were to stay the same throughout its life in 2014, and the factors that probably are related to the life expectancy at birth. So the sample size is 55 countries. All the data which are dependent and independent variables are from website Our World in Data. The others information like how I elaborate the variables are from journal and article that are in the internet. So variables are divided into two, dependent and independent. So basically dependent is Y and independent is X. So dependent is life expectancy at birth, and independent variables are current health expenditure, population in log, share of people who trust doctors and nurses in their country, estimate of current tobacco use prevalence, GDP per capita in log. So as we can see, there are two types of variables in independent that are used in log. So we can see that it is a level log regression. I used log because I wanted a smaller value so that I can plot the data easier. So later we can interpret the coefficient as a percentage increase in independent results in divide 100 unique increase in dependent. So that is a level of model. Here I will be explaining about the dependent variables. So current health expenditure, the current level of health spending reported as a proportion of GDP. Healthcare items and services consumed during each year are included in estimates of current health costs. Capital health expenses such as buildings, machinery, information technology, and vaccine stocks for emergency or outbreaks are not included in this index. Next, population. The number of population that can survive the life expectancy at birth. The total population is calculated using the population factor definition, which includes all residents regardless of legal status or citizenship. Share of people who trust doctors and nurses in their country. This I take it from annual in percentage. Estimate of current tobacco use prevalence. The age I standardized. Annual is in percentage. GDP per capita, current prices and current exchange rates per capita USD. As I mentioned earlier, population and GDP per capita I use in logs, so I can have smaller value. So now we have econometric model, which leads to LE is equal to beta 0 plus beta 1 HT plus beta 2 log P plus beta 3 SPT plus beta 4 ECT plus beta 5 log GDP plus U. So I use short form so that I can simplify the model. So beta 0 represent as a constant of intercept. Beta 1, beta 2, beta 3, beta 4 and beta 5 represents the elasticity. U refers to random error. After we have collected our data and have the model which is in level log regression, we can continue with chapter 4, which is result. So with the data that I have obtained, I managed to make 5 graphs which are in scatter plot. So first is about life expectancy at birth, versus current health expenditure. As we can see, the red line is going upwards. So LE has a positive linear relationship with CE. Next, as we can see, the line is going downwards. This is a negative linear relationship. So LE has a negative linear relationship with B. LE has a positive linear relationship with SPT as the graph is going upwards. Fourth, LE has a negative linear relationship with ECT. Last, LE has a positive linear relationship with GDP. And then after I have the data of 55 countries, I calculated the mean, standard error, median, standard deviation, sample variance, characteristics, skewness, range, minimum, maximum, sum and count. So we go one by one. So the first independent variable, which is current health expenditure, which is written as HE. From the data, it can be concluded that the average of current health expenditure that's spent by the country is 6.460162% from the total share of the nation's GDP. The minimum value of current health expenditure that's spent by the country is 2.667437%, which is Benin, while New Zealand recorded as the country that spent the highest compared to others country by 10.56704 from total share of its nation GDP. Next, log population. Based on the data, 50.89052% is the average population in log that occurs in all 55 countries that were used in this study. So, Tunisia about 11.5231%. People survive up to age 72 years. It was the minimum population on 2014. Next is SPT, share of people who trust doctors and nurses in their country. By looking at the data, it can be concluded that the average of people who trust doctors and nurses in their country is 82.53%. Next, ECT, which is estimate of current tobacco use prevalence. So the mean, the average is 21.8454%. The minimum of ECT was 4.1% in Ghana, while in Myanmar was the highest, which is 48.8% in 2014. Last, log GDP per capita. The mean is 9.284663%. So for the dependent variable, which is LE, life expected at birth, and independent variable HE and ECT, which are current health expenditure and estimated of current tobacco use prevalence, it has a right skewed, which is positive skewed. So for the others independent, which are log P, SPT, log GDP, has a left skewed, negative skewed. So how did I calculate either it is negative or positive? I take a look in the mean and the median. If the mean is less than the median, it has negative skewness. It is negative skewed, sorry. If the mean is larger than the median, it is a positive skewed. So the variance is bigger when the group contains a wider range of number and smaller when the group contains a narrower range of number. Next, correlation analysis. So in this table, we can see that the correlation matrix between the dependent and independent variable of life expectancy at birth in 2014. It shows that population in log estimate of current tobacco use prevalence have negative correlation with life expectancy at birth, while current health expenditure share of people who trust doctors and nurses in their country, and GDP in law having positive correlation with life expectancy at birth. The correlation coefficient along the diagonal of the table are equal to 1 because each variable is perfectly correlated with itself. So as we can see in the table, the correlation between share of people who trust doctors and nurses in their country and GDP per capita in law is moderate with value 0.5. However, there is no multicollinearity among the independent variable as all the correlation value are less than 0.7. So it can be concluded that there is no perfect collinearity between the independent variable. As a result, it is defined as the fraction of the sample variation independent y that can be explained by independent x. Based on the table, R square value overall is 0.3735. It means that the regression explains 37.35% of the total variation in the life expectancy at birth can be explained by the current health expenditure, population, share of people who trust doctors and nurses in their country, estimate of current tobacco use prevalence, and GDP per capita. Okay, from this table, significant F, which is 0.0002618 to 1, is lower of the alpha 1%, 5%, and 10%. So it is a reject the null hypothesis testing. The F states is 5.84411716. Using the F distribution table for alpha 0.05 with numerator of degree of freedom 5, df for regression, and denominator degrees of freedom for 9, df for residual, I find that F critical value is 2.404. Since F statistic 5.841716 is greater than F critical value 2.44, so it can conclude that the regression model as a whole is statistically significant. The two variables, which are population in law and share of people who trust doctors and nurses in their country, are jointly significant. They were not significant when tested individually. Okay, from this table, significant F, which is 0.0002618 to 1, is lower of the alpha 1%, 5%, and 10%. So it is a reject the null hypothesis testing. The F states is 5.84411716. Using the F distribution table for alpha 0.05 with numerator of degree of freedom 5, df for regression, and denominator degrees of freedom for 9, df for residual, I find that F critical value is 2.404. Since F statistic 5.841716 is greater than F critical value 2.44, so it can conclude that the regression model as a whole is statistically significant. The two variables, which are population in law and share of people who trust doctors and nurses in their country, are jointly significant. They were not significant when tested individually. Okay, this is the last table which contains the coefficient. So this table illustrates the result of multiple regression model for this study. The population regression function for this study is as following: LE equals to beta 0 plus beta 1 HE plus beta 2 log P plus beta 3 SPT plus beta 4 ECT plus beta 5 log GDP plus U. So we can take the value from coefficient into this method, into this regression, which can be LE hat equals to 58.75 plus 1.19 HE minus 0.99 log P plus 0.03 SPT minus 0.18 ECT plus 2.35 log GDP. The number below the regression are the standard error. So the coefficient on the explanatory variable disclose a lot about the relationship between the dependent and independent variables from this equation. Beta 1, the coefficient on the current half exponential is equal to 1.19. From this coefficient, it tells us that for an increase in the current half exponential coefficient by 1, we can assume that the life expectancy at birth will increase by 119%. Current half exponential is positive relationship with life expectancy at birth. However, beta 2, the coefficient on log population is negative 0.99, indicates that increase in the population in log coefficient by 1, the life expectancy at birth will decrease by 99%. I predicted an inverse relationship between these two variables because an increased population in log will result in an increase in life expectancy at birth. It's the coefficient on beta 3, share of people who trust doctors and nurses in the country is 0.03. This shows that an increase in share of people who trust doctors and nurses in their country by 1 will result in an increases of life expectancy at birth by 3%. So, share of people who trust doctors and nurses in their country has positive relationship with life expectancy at birth. Beta 4, the coefficient of estimate of current tobacco use prevalence is negative 0.18. Indicates an increase in the estimate of current tobacco use prevalence coefficient by 1. The life expectancy at birth will decrease by 18%. It has negative relationship between the estimate of current tobacco use prevalence with life expectancy at birth. Last, the coefficient beta 5 log GDP is 2.35. This shows that increased GDP per capita in log by 1 will result in an increase of life expectancy by 235%. So GDP per capita in log has positive relationship with life expectancy at birth. So to conclude what I have said, only the estimate of current tobacco use prevalence have negative relationship between the only have negative relationship with the life expectancy at birth, while beta 1, beta 2, beta 3, beta 5 have positive relationship with life expectancy. So, okay, next p-value. In this model, by looking at the p-value, it can be seen that only 3 variables, which are current half exponential, estimate exponential, and GDP per capita in log are significant at 1%, 5%, and 10%, while estimate of current tobacco use prevalence is significant 5% and 10%. The other two independent, which are population in log and share of people who trust doctors and nurses in their country, were not significant at any level below 10%. Let's conclude sharing. Since the data from the dependent and independent variables did not come from the same file, I assume that all of the independent variables were related to the dependent. So as a result, the primary goal of this research is to determine whether or not they are related. So the overall results can be said that just one result different from the hypothesis, since I expected that log population will have a positive relationship with life expectancy at birth, but at the end the result shows that it has negative relationship. Other than that, it also can be said that from all 5 independent variables, only current health expenditure, estimate of current tobacco use prevalence, and GDP per capita in log are important and significant with life expectancy at birth. All of the errors that occurred during the study could have been caused by my faults in selecting the independent variables and data sets. So that is all for me. Thank you.